Okie dokie then, guys, let's have a look at number 2. We've got a quadratic here, all arranged in the standard form. The power to x squared is here, the number of x's is here, and 12 equals 0. That's how we want to arrange it before we do the factorization. So let's have a go at that then. Underneath it we draw a pair of brackets, and we write 2 lines for the first, 2 lines for the second. Doesn't take a moment to do. And then we use this key here, first line, first term. So what times what? There's the first line product. And that product gives x squared the first term, doesn't it? So straight away, that's easy. We can just write x and x. It's the easiest thing to do. The last line is the next thing to do, is the last term. We've got 12. So remember the symmetry thing? Because this and this bracket are the same, there's an x and x. Doesn't matter which way around you write these products that give rise to 12. So the last line, line 4, this product here and here, there and there, that line 4 must add up to plus 12, mustn't it? So there's 12. How would we do 12? Well, we do 12 and 1. We don't need 1 and 12 because of the symmetry property of the x and the x being the same in both brackets. So I don't need to write 1 and 12. So 12 times 1, we've also got minus 12 times minus 1, haven't we? And then minus 6 times minus 2. And then we've got 6 times 2. And then we've got 3 and 4, haven't we? 3 and 4. And minus 3 times minus 4. Okay, so that's the second piece of the jigsaw. The second easiest thing to do, last line, last term. Now we need to look at the middle lines to fit the thing together for the middle term. The middle term is minus 7x, and the middle lines is that many x's, is line 2, plus that many x's. So, as we said, it doesn't matter which way around you write it. So many of these, and so many of these, or one of rather, and one of those, because there's one lot of x, isn't there? So line 2 would be x times what number this is, and an x times what number this is. So one of those and one of those must add up to minus 7, mustn't it? So we go down our list, and we see that's minus 8, that's minus 13, that's 13. Nope, 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 nope. Until we get to 1, which when we add them together, like minus 3, and then if you add minus 4 to that, take away 4, in other words, you get minus 7, don't you? So it doesn't matter which way around we write the order. As we said, it could be minus 4, minus 3, or minus 3, minus 4. So let's put that down then. Minus 3, minus 4. There we go. So let's just write it more tidily so the reader can see what we've written there. Okay, so that's factorized. Great. And then we say this product must equal 0. It can only equal 0 when either this equals 0, and that gives equals 0, and that gives rise to x equals 3 when you move the 3 over. There we go. And then the other time this product can equal 0 is when this equals 0, isn't it? And that means that x, move the 4 over, minus 4 to 4, and that gives you x equals 4. So the solutions then to this quadratic equation are x equals 3 and x equals 4. So notice we sped up quite a bit, didn't we, in this question? And as we proceed, we'll get faster and faster and faster at doing these things, so we can just rattle them off. But as I say, this is the fail-safe method, and it's the easiest way possible that I'm aware of, and it's nice structure to it, so you can exactly see what piece of the jigsaw goes together to solve the problem. Right, let's go on to the next one. Next one, number 3, yeah.